Look, I want to make a crafting system to go with our inventory system because we have all of these items, but now what can we do with them? But before I can make anything to do with crafting, we need a way to query the inventory. And what I mean by that is we need to be able to take an inventory and just check, hey, do you have this item? And how many of this item do you have? Because if we're going to be able to do some crafting stuff, we need to see, okay, this crafting recipe takes 5 wood and 3 stone. We need to be able to check whether or not those are in the inventory. And at the moment, we don't really have a convenient way of doing that. And once we've implemented a query system, we can also do other things like having specific doors in our game that take some kind of resource, like gold out of your inventory, or maybe you need to have a specific item like a key in order to unlock a door. That's all going to be very easily implementable once we can query the inventory like that. So let's open up our inventory components here because we haven't done that in a while. We have a bunch of functions here already, some of which I don't think we actually use anymore. I don't think like the swap slots function gets used anymore since we updated the drag and drop system, but let's ignore that for now. We're going to be making a new function here and we'll just call that query inventory. The function itself is actually going to be remarkably simple. We just get the inventory array and we're going to loop over that, obviously. We need to check every single inventory slot to see if it holds a certain item. In that, we're going to break the inventory slot structs to get the information out of it, and we will just simply check whether or not the item asset is equal to our item asset that we're going to be inputting. And let's call this input the item to find. Cutting in here during editing, if you just pull off of this equal node here and put that in as your input for your function, it's going to be a generic object reference. And we want this to specifically be a item object reference. So we want to make sure that it is a BP item instead. Now, in order to make this a little bit more usable and a little bit more simple, we're going to also be checking whether the stack size is greater than or equal to a amount that we're going to be looking for. So we do that as well. We'll just call that amount. There's one thing that I do want to note, and that is with this simple version of the query system, if you have 2 stacks that add up together to having that amount of that item in your inventory, this is not quite going to register that because it's only going to be checking the inventory slots one at a time. What we'll do here is we'll check both the item asset and the item amount, and then we're going to check that on an AND. So both of these need to be true. And if both of those are true, we're going to go into a branching node. We will add in a return node. The return node is going to have 2 outputs, and the first one will be found item, and the second one will simply be the array element that we found. So that will be the item slot or the inventory slot. So inventory slots. And of course, in this return node, the found item will be true. If we make it through the entire for each loop without finding something, we pull off the completed pin and we add a return node for found item false. And of course, that doesn't have an inventory slot to go with it. This is the entire query function, the simple version, just to show off how you can make the slightly more complicated version that will return you an array of inventory slots that are relevant. I will make 2 versions of this. So we'll make this query inventory single slots, and then I will just duplicate this over to query inventory multi-slots. The input will still be the same. We still have an inventory. We're going to be for each looping over this, but we're going to be making a couple of local variables. And the first one will be the amount found, which will be an integer. And then we'll also have a second one here, which will be the slots that we have found. And that will be of type inventory slots. And we will make that one an array. So what we're going to be doing here is we're going to be changing a couple of things around. We're going to, for now, get rid of both of the return nodes as well. And once we have found an item, we first want to check whether or not this is greater than or equal to, but we want to actually check whether or not the amount found is plus the stack size is greater than or equal to. The amount found is going to start out at 0, but once we have found something and it is by itself not greater or equal to, then we just add it to the amount found, and the next time we find the slots, it will be able to add those things together. So also get rid of these branches here actually, because we need to do some other stuff. So in this version of the function, the moment we find an item that matches the item that we're looking for, we're going to be adding that to our array slots here. So we'll add to that, and we'll just add the slot that we are currently working with. So we'll put in a branching node for that, and the equal check here is going to be the first thing. Then we'll add, and after that, what we'll do is we'll check, is the amount we already found plus what we have in this slot going to be equal or greater than the amount that we're looking for? Because if so, what we'll do is we'll then do a return, and the outputs for this one are still going to be found items, which will be true in this case, obviously. But then also the inventory slots, plural, because of course this is going to be of type inventory slots, but this will be an array that we're going to be returning. And of course that will be the slots found array that we've made here as a local variable. If the amount found plus the stack size of whatever we just found together is not sufficient to trigger this return node, what we're going to be doing, we're going to set the new amount found to whatever this value is. So the old one plus whatever stack we just found. And then it will go to the next inventory slot and it will check the same thing again. Is it the same item? If so, it's going to add it to the slots that it has found. Then it's going to check, hey, does adding everything in this slot make us go over the amount that we're looking for? Yes or no? If yes, then we can actually finally return. If no, we're going to keep going and keep going and keep going. And for this one, it's actually very, very easy, because if we ever reach the end of the for each loop without getting to this return node, we know that the entire inventory altogether doesn't have the right amount of resources for what we're querying for. So in that case, we can simply just return with an empty return node. So this is a slightly more complicated version of it, but it might be useful to have both versions for a single slot, which is just the easiest to set up and for the most part what we're going to be using, but sometimes maybe being able to check multiple slots together, especially for things like the crafting system, is going to be quite nice. So for testing purposes, what I want to do here is I just want to make a new blueprint class, and we'll just make that an actor, and we'll call that something like BP door, and I'll add a cylinder just because, as well as a sphere collision. The sphere collision is going to have a radius that is quite a bit larger than the cylinder itself. And then in the event graph on begin overlap, we just check, is the other actor equal to get player character? If it is, we'll get the player character's inventory, so we get inventory. I should point out that this just returns the main inventory components and not all of the different inventory components that we have, so it doesn't return things like the inventory component for the hotbar. So if you have an item on your hotbar, it's not going to be queried in this case. We could update this to return an array of inventories so that a actor can supply all of their inventories when being requested with this blueprint interface. At the moment, I don't care enough to do that, but you could if you wanted to. And then we're going to use the query inventory. And this one, we can just do a single slot. We will only just check whether or not we have at least one of these. And then we can check for, let's just check for the sword real quick. And then if it has a found item, what we will do is from that inventory component, we'll just subtract an item. And item we'll subtract is going to be from the slot that the sword is in. So that's going to just like take that index, put that in there. And then at the very end, we can like destroy this actor, the BP door, that is, because it's a door, you can make it play an animation instead or whatever. So if we put this into the level here, just in a random place real quick, we can see if we walk up to this, nothing happens. But if we pick up the sword and we walk up to it, it'll disappear because it queried the inventory. It saw, hey, you have a sword. If we open the inventory now, we see we don't have a sword because it deleted it. And that's how you can very easily make items, blueprints, things in the world that query your inventory and check for you to have a certain something in order to be able to progress. And while we're at this, because I mentioned it, does actually, instead of changing this to an array, what I would probably prefer to do is keep the inventory slot itself here, but then also add in an array for any extra inventories, and you can just like make that into an array like that. So every bit of existing code will still work because of course it's still just displaying itself an inventory. But now if we go into our third person character, for instance, what we can do is in this blueprint, in the get inventory, instead of just returning the inventory components, we can get both of these together. We can make an array out of that and then return that array as well. So if we need to, for whatever reason, get both of these inventories because we want to query both of them or whatever, we now can. So that makes it a little bit more intuitive, because otherwise if you have something in your hotbar, it's not going to be able to query it or whatever. It's a little annoying. So going back into that door, if we like compile and we go into get inventory, what we can do instead is we can put that into a for each loop. So no matter what character interacts with this, how many inventories they have, it will also always work. So do a for each loop, switch the target around, loop body, and now it'll also work with the hotbar. And then also the subtract item needs to be taken from the loop, of course. So just to show you that, we can now pick up this sword if we wanted to, and we can just put it in the hotbar. And if we walk up to this, it removes it from the hotbar as well. So we have a good querying system now for the inventory. And with a good querying system means that we can look through the inventory for specific items. And that's going to be the cornerstone of being able to set up a basic crafting system. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sir J. Thomas,